Well, good morning, good afternoon, or good evening, depending upon where you are in this world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, your moderator for today's event, and I welcome you. We have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it afterwards on demand. We'll be sending out an email following the webinar that will include a link to take you right to the webinar on demand. And we are taking questions from the audience. So if at any time during the event you have a question for our panelists, please don't hesitate. Just use your GoToWebinar control panel and submit your question. We'll take probably around 10 or 15 minutes or so near the end and go through the audience questions. Okay, with that, we'll go ahead and kick off today's webinar, Beyond S3 Buckets, Effective Countermeasures for Emerging Cloud Threats. Our speaker today is Matt Chiodo, who is VP of Cloud Security at RedLock. Hi, Matt, how are you?
I'm doing well, Charlene. How are you?
Great, I'm doing great. Thanks for joining me today. I'm going to go ahead and turn it over to you now.
Awesome. Thanks so much. Well, thanks everybody for joining today. We're excited to chat about this topic. We decided to give the webinar this name for a couple of reasons, but the number one was just that, it seems that S3 buckets are in the news almost on a weekly basis. Some developer somewhere has inadvertently uploaded data to an S3 bucket, and now it's on national news or worldwide news. And so we wanted to talk a little bit about S3, but not just S3, because there's just so much more that's actually happening, and we'll share this with some of our research that's happening in cloud environments beyond just S3. So before we do that, just a little bit of background on myself. I've been focused exclusively on public cloud for just over 8 years, and I've had the opportunity to work with some of the largest companies in the Fortune 500. This has given me just a lot of good experience working with, across multiple industries. And, prior to even the time when I was at RedLock, I was the head of global cloud security at Cognizant Technology Solutions. For those of you who are not familiar with Cognizant, it's a massive organization with just under 300,000 associates worldwide. So without any further ado, let's walk through the presentation a little bit. So we organized it this way. We'll talk a little bit about what we're seeing with our research, both now and how we think this is going to change over the next 6 to 12 months. And then we're not just going to leave you with things to worry about. We're actually going to give you countermeasures that you can put in place today to defend against everything we're going to talk about in the presentation. So we're actually going to give you some very actionable things that you can do today to defend against these things. And then towards the end, we're going to do a live demonstration of the RedLock platform so you can see how you can defend against some of the things that we'll chat about today. And hopefully all goes well. It's a live demo, so it's not recorded, so we'll do it live on the fly. So that always makes things fun. And then we'll be sure to leave 10 to 15 minutes at the end to answer any questions that you might have, either about the content or about the RedLock platform. So if that makes sense, let's just hop right into some of the information. So all the data that I'm going to share with you today has been produced by our Cloud Security Intelligence team, or our CSI team. And this is a great team, right? And there's really 3 personas that make up this team. The first is security analysts, right? These are the folks that are triaging security alerts as they come in from our proprietary tools that we use to scour the internet looking for security vulnerabilities. The second is the data scientists. I like to think of these as mad scientists that are coming up with all different types of algorithms to make sense out of the data that's coming from all of our sensors. And then the last one is the data engineers. Data engineers, these are the folks that make it possible. They're the ones that manage the Hadoop clusters and things like that, but also actually get into figuring out how do we solve some of these big data problems and how they relate to security. And the team really has an interesting mission, right? So it's threefold. The first is, yes, they're out there, they're researching the data and the threats as they come in through our tools, but then not just digging deeply into those, but then actually coming out and advising on best practices, how you defend against them. And the third one then is, if you're a customer of RedLock, you get to take advantage of this team because they then publish policies based upon the research and the best practices, and you get those by default as part of the RedLock platform. And just some of the things that this team has done over the last year or two. The first one is probably one of the biggest, and that's they discovered a treasure trove of information that was out there on the internet, all nearly 11 million PHI records, so very sensitive data. And then there's another one which was very public, and we'll talk about that a little more later in the presentation, for a next generation taxi company where they had some very sensitive data that was exposed. We typically release our research just about 3 times per year. You can see below there, our most recent report was from May. If you click on that link, put it in your browser, you can download that report. There should be the next one that's coming out very soon here in Q4. So the first part of the research that I wanted to share with you really has to do with risky public cloud storage configurations. What we're seeing from our research is just over half of organizations are exposing some type of public cloud storage service in a way that they probably did not intend. So this is what, again, we are seeing in the news on almost on a weekly basis. This is the S3 bucket that's put out there with some type of sensitive data in there that's being exposed to the entire public internet. These are these types of services, right? So this is not just S3, this is any type of public cloud storage service that's being exposed in a risky type way that the company, again, probably did not intend. The second one is around vulnerabilities. So for those of us who have been in security for any period of time know that we've been talking about patching for decades, it seems, decades. But we're seeing that nearly a quarter of organizations are missing high severity patches in their public cloud environments, right? So this is probably might be lower than actually the on-premise environments, but we're still seeing almost 25% of organizations are missing high severity patches. This is critical because it shows that in public cloud environments, and I'll qualify that when we say public cloud in this presentation, we're talking specifically about infrastructure as a service and platform as a service in those companies like Google Cloud Platform, Microsoft Azure, and AWS. That's really what we're talking about when we say public cloud. But it shows that organizations are really struggling with kind of getting their arms around both the configuration as well as patching in their public cloud environments. So although S3 buckets continue to grab the headlines, cryptojacking is one thing that we want to really talk about, because this is something that has barely made the news over the last 6 to 12 months, but we're seeing it become fairly pervasive in public cloud environments. So I think everyone will probably have heard at this time around cryptocurrencies, things like Bitcoin and Ethereum. But what most people don't know is that beyond those two, there's actually over 1,600 cryptocurrencies that exist today. And there's a number of reasons why, right? They're decentralized, they're a virtual currency, they're not controlled, at least today, by any central government. And so they become very attractive both to individuals that are probably nefarious as well as completely legitimate uses, right? So the reason, and we'll get to this in a moment, that this is really critical for your public cloud environments is that, back in 2009, when Bitcoin was first launched, it was fairly easy to mine a new coin. And this is by design. So the creators of Bitcoin created the algorithm in this way. So at the very beginning, when there's very little currency, just a simple desktop computer with a single CPU could very easily mine a coin. But over time, as the popularity of the currency grew, the algorithm, or the mathematical puzzle is another way to look at it, has purposely gotten harder to solve, and it requires more and more compute power. And so again, back in 2009, it was very easy to mine this. But over time, that algorithm has gotten much more difficult, and we have seen the rise of groups or teams of servers that are required to actually mine just a single coin. And that's by design. But it requires things like big GPUs, graphic processing units, that don't typically exist in a large capacity. Now, this is really important, and this is really why this applies to your public cloud environment. So despite, this is interesting, right? So this shows the price of Bitcoin over the last year. And you can see that, early part of the year, it hit its max of almost $20,000 per coin, and now we're just south of 7,500 as of just last day or two. So, but despite it being going up and down, it's really captured the attention of hackers. And you're thinking, well, how does this relate to public cloud? Well, the reason being is that this is a new threat vector for your public cloud environment, because we're seeing attackers go after compute power in public cloud environments rather than going to steal your data. Now you might think, well, I'd rather someone to go after my compute power than steal my data, but it's still a new attack vector that you need to be very aware of in your public cloud environments. The reason being is that in an on-premise environment, you typically do not have any type of elasticity, right? You may have very limited elasticity in terms of your compute power, but it's typically very fixed in an on-premise environment. So that's one thing you need to keep in mind, is that it's typically fixed, the compute power. But when you think about an AWS or a Google, any one of those cloud providers, it's very easy to go in and just spin up as much GPU power as possible. So that's why cryptocurrency or cryptojacking has become a very big target in public cloud environments. And our research shows that we're seeing right around a quarter of organizations have some type of cryptojacking activity in their public cloud environments. This is actually really high. If you would look at what it looks like in an on-premise environment, I guarantee you this number would be much, much lower. Again, going back to the fact that on-premise environments don't really have that elasticity, and they typically don't have, unless you're a very specialized type of organization, you also don't typically have those GPUs that the attackers are looking for, which are readily available in a public cloud environment. So let's talk about, and this is the one I alluded to at the beginning. So we say a next generation taxi company. So this is our CSI team, as part of their security research, was looking through some of the logs that were coming in from our sensors, and we discovered this one because it looked fairly juicy. And so following a secure responsibility process, we went through and we started to triage this. And so it's pretty easy. If you go out and Google this, you can figure out which company this is very easily. But what we noticed was that hackers had infiltrated this company's AWS environment by their Kubernetes console, and they didn't use any type of advanced hack. An administrator had brought this Kubernetes console up, and it wasn't password protected. So it was very easy to get into. And this, again, shows just how difficult it can be to really get configurations under control in public cloud environments. And because it was open, it was leaking AWS credentials. As we started to look around in the environment, we had no idea whose it was. We didn't know what company it belonged to right away. We noticed that there was a crypto mining script that was running in one of the pods. And as we began to look further around, we noticed that not only were the access credentials being exposed, but there was actually vehicle telemetry data in S3 buckets that was being exposed. And so to this company's credit, we followed their responsible disclosure process, and they resolved this issue very, very quickly. That's not always the case, but to their credit, they really did address that very quickly. And so this is just one of many responsible disclosures that our CSI team has found over the last year to year and a half. And it just kind of goes to show what we're seeing in terms of cryptojacking and how they go after your environments. So let's talk in terms of countermeasures, right? So how can you defend against this in your public cloud environments? We have three things that we would recommend as part of our CSI research. The first is implementing a deny all default outbound firewall policy. Now, this is something that has actually been talked about for quite a long time as a best practice, specifically in public cloud environments. But our research shows that almost 85% of companies are just simply not doing this. And it's more than likely because when you think of an on-premise environment, this is not something you would typically do, right? The on-premise environments, we typically see that there's a lot of trust. Once you're inside the network, it's considered a trust zone. And I think that mentality has unfortunately carried over to public cloud. But this is something that if you implement it, it can really negate a lot of not only cryptojacking, but also other security type things such as command and control. We know that once an attacker is able to penetrate a single system in any type environment, the second thing they usually try to do is, can I open up a channel back out, right? think of command and control. So if you implement a denial outbound firewall policy, a lot of times you can block not just cryptojacking, but many other types of attacks as well. The next one is to rotate your access keys regularly, right? So access keys, right, they're basically like usernames and passwords. They are long-term access credentials. What we're seeing is that companies are not doing this, right? Almost half of organizations have not rotated their access keys in almost over 90 days. So just like a password, most companies have a 90-day rotation policy. You need to be doing the same thing with your access keys, because what inadvertently happens is a developer will upload access keys as part of code to something like GitHub. And there's all types of tools that are out there that allow people to go out and scan GitHub for access credentials. And once they find them, they will use them to compromise your environment and either get access to your data or, again, do cryptojacking, things like that in your environment. Now, one option that we don't have here actually is not only should you be rotating access keys, but you need to look at is, do you actually need to use them, right? There are alternatives such as IAM roles. So if you look at something like AWS, they have these temporary access credentials that are generated as the application runs. And that's something to also consider, is to say, hey, is it better in my environment to actually utilize those IAM roles, those temporary access credentials, rather than the long-term credentials, access keys? So consider that as well. It might be something you need to have a conversation with your developers about. And then the last one is really just monitoring your network traffic in your public cloud environments. And this can be difficult to do. Now, all the cloud providers do give you a certain level of visibility into your environment, but because of just the verbosity of the logs, sometimes it can be difficult to do natively. But we encourage you to make sure you're actually looking at the traffic that's leaving your environment and look for those that are going to those popular mining servers, things like Ethereum and Bitcoin, right? You can get those from blacklists. You can also look at those most used ports. Those are ways that you can kind of search on that traffic to see what's happening in your environment. So the next one we want to talk about is instance metadata APIs. Now, typically when we're doing this presentation, if we've done it with a live audience, we typically ask for a show of hands just to ask, how many people have even heard of instance metadata APIs? And typically, if we have a group of 50 or so and we ask this question, maybe one hand will go up in the room, maybe one hand. And so this is an area that just most people are not aware of. This is something that exists in all public cloud environments. And specific to this, I want to share just this one CSI finding is, we see about 27% of organizations are experiencing some type of potential account compromise. And the reason that this is relative is that in order to take advantage of the instance metadata API exploits that we'll show you in the next few slides, you have to have some kind of account compromise first. And so you can see that it's pretty prevalent, 27%. So let me just give you a quick background so you can wrap your minds around what this is and how it can affect your environment. So all of the cloud providers, Microsoft, Google, AWS, they all provide some type of native identity and access management as part of their core platform offerings. And all of them do a really good job with that. But what most people are not aware of is that anytime you instantiate or you launch a virtual machine in any one of those environments, it also creates and adds some metadata about that server that you launched. And it includes really useful information. It includes things like the name of the host, what security groups it belongs to, but also things like access keys. And so if you look at the screenshot that we have here, you can see that we ran this command from a VM that was running in AWS. And you can see we ran a simple curl command. We're calling this instance metadata API. And you can see two key things that are in here, right? It's coming back with the access key. So you can see where it says access key ID and then secret access key. That's basically a username and password. Now, this was run from a host, right? But so you need to understand that this is not a bug, it's not a vulnerability or an exploit. But if you don't know that this exists in your environment, it's very difficult to take steps against anybody that's trying to abuse this in your environment. So we wanted you to be aware of this. So let's walk through two ways that someone could potentially take advantage of this and exploit this in your public cloud environment. So the first one is, this is if someone was trying to exploit this via a vulnerable reverse proxy. So we know that especially in hybrid cloud environments, proxies are extremely common, right? Especially in public cloud. People put them up for a number of reasons. It could be for security reasons. It could be for any number of reasons. And part of our CSI research, we found that there are literally, dozens of proxies out there that have insecure host header configurations. And so if you look at that first screenshot there, it shows an example of a poor Nginx configuration. So in this specific case, you'll see where it says proxy underscore pass, and then it has HTTP $host. So what an attacker could potentially do in your environment is, or someone nefarious, maybe an insider, they could set up a Nginx, which is a proxy software. It's very highly used by many companies, and they could set it up this way. And that $host would really be configurable by the attacker or the user. They can set that to be whatever they want it to be. And as you can see here, is that anybody, let's say you have a VM, and let's say it's utilizing this incorrectly configured proxy. As your traffic goes through that host, it's actually executing this and storing that instance metadata information that would be for that host remotely. So in this case here, you can see in the below screenshot here, you can see we executed another curl command, and we've specified the host, that 169.254.169.254 host. And that would be the host that would be going through this proxy. And you can see here that we are able to dump that access key ID and the secret access key ID. And we're now able to get access to, with that information, whatever access was given to that. And so this is just one example of how someone could potentially exploit this in your public cloud environment. And I also want to show you a second one as well. This one I think is probably even more pervasive and definitely more dangerous. So I think most folks now are very familiar with Docker, right? Docker has really made its way into the enterprise over the last year to 18 months. It's become very popular for many good reasons, right? So developers were tired of trying to manage all the dependencies for their applications, and Docker really abstracts all that, right? It's all the dependencies, and you can very easily move it between multiple machines. And Docker Hub specifically is a place that many developers are sharing images, right? So they have an application and they want to share it with a community. They upload it to the Docker Hub, and vice versa. Now, the rub here, though, is that a lot of developers have started to rely upon those images that are up in the Docker Hub, and they're really starting to just blindly trust these. And there's not really any in-depth security that's looking at, well, what's actually in this Docker container. And so that's really the challenge, right? So your developers may have applications that they're building for your organization, and maybe they're just doing a pull on it on maybe a monthly or whatever the basis is. And as you start to pull this into your environment, the problem is that it's not difficult, and this has been done before, for an attacker to actually embed a malicious command into the Docker file. And then every time it's pulled into your environment and it's actually built, specifically the on build command, it'd be very easy to include this so that it calls the instance metadata API. So as you can see here in the image, we're showing you how you kind of build on top of it. But now, let's say it was good to begin with. Maybe they've been using it for 6 months, 9 months, and then all of a sudden someone adds this into that base image. So it's very easy to see it. Now, a lot of times the response to this to most people has been, well, I know this is possible to do, but if something does happen, it's limited just to that Docker image. It's contained. But the challenge is when you're looking at a public cloud environment and you're talking specifically about these instance metadata APIs, the scope of the attack greatly is broadened now, because it moves from outside, it moves from just that small Docker container to now your entire public cloud environment. Whatever access that access key had to your public cloud environment, now the attacker has to your entire public cloud environment. So it really moves beyond just the Docker image to possibly your entire public cloud environment. So this is one that I think is actually much more pervasive and much more dangerous in your environment than even the first one that we showed. So as I mentioned, we're not just going to leave you with things to worry about. We're actually going to give you some actionable ways that you can defend against this in your public cloud environments. So the first one is you need to monitor what your users are actually doing in your public cloud environment. And this is really difficult to do. Public cloud environments have really introduced a whole new level of logging that did not exist in your on-premise environment. Specifically, if you think about public cloud, you still have all of you have server level logs, application level logs, all those types of things. But now you're adding on this whole new API layer, right? This whole new API layer. And so it becomes really difficult to monitor what your users are doing, especially if you're dependent upon a human to do it. There's just too much data. This is where technologies such as UEBA can actually help you to baseline what's normal in your environment and then be able to alert on anomalies, right? This is typically done through some type of machine learning, right? So that's the first thing. You need to be able to employ some kind of technology that will help you to build a baseline and then alert on what's not normal. And then the second one is just to determine and do research in your public cloud environments to determine, are they actually being used, right? And then just simply follow the principle of least privilege. So one thing that you can do right away is you can utilize IP tables, right? This is a Linux-based firewall to make sure that only the root user can access the instance metadata API. So you can actually make it that way. This would almost completely negate what we just talked about, that second exploit. So let's talk about that, right? So if somebody was in let's say that someone did download a malicious Docker image, and let's say it has that embedded malicious command to call the instance metadata API. They're not normally running as root, or at least they should not be in your environment. If it calls it and you have IP tables correctly configured so that it's only allowing the root user to call that instance metadata API, it's just going to be blocked at the network layer. So this is something very simply, it doesn't cost anything to do. It comes by default with Linux. You can also do this with any other type of host-based firewall. This is something you can do very quickly to block this type of threat. The third one is more broadly to do with just your network traffic in your environment. You need to assume that there's going to be a breach of some sort that happens in your environment, and you need to know what's normal. So this is very similar to the first one. You need to use some kind of technology, basically some type of machine learning, and understand what's normal in your environment, and not just look at north-south. Don't just look at the traffic that's going from the internet into your environment, but actually start to really dig into what's happening as far as east and west. So we know that attackers, they gain a foothold, they try to open a connection back up out to the internet, and then they start to look laterally in your environment to understand, hey, what else can I get access to? So you need to make sure you're monitoring that cloud traffic inside your environment. And then the last one is just make sure you're auditing your Docker images, right? So again, because Docker has really taken the enterprise by storm, really just over the last year to year and a half, a lot of corporate security programs really have not started to look in depth at their Docker images. And so make sure you're actually reviewing all of it. Typically, you use some type of security software, and you'll actually create a repository, and these are your trusted images. Developers will then typically pull those into that trusted repository. They'll be scanned, and then that's considered like kind of your gold images. That's what you really want to be looking at here. Alternatively, if you have not invested in any software that will audit the Docker images, there are some open source tools that can do that, but you want to be specifically reviewing the on-build commands. These are things that are really important to look at. So this is, I think, probably the most exciting part of the demo, of the presentation. I'm going to walk you guys through a live demo of the RedLock platform. You can see how we address some of these specific issues. And hopefully, if all goes well, you'll be able to get a really good feel of what things look like within our platform. All right, so first thing I wanted to walk everyone through is just kind of get a feel of what our console looks like. So this is the dashboard. This is a demo environment, so we obviously have things fairly juicy in here, so you can see things lit up. So let me point out a couple things here. First is, a lot of times we get asked the question, well, how difficult or what is the effort required in order to set up the environment? And it's fairly straightforward. If you look at this here, when you want to add a new public cloud environment, it's fairly straightforward. You would click Add New, you would give it a name, whatever it might be, and you start to plug in. So specifically for AWS, there's 3 pieces of information that you would need to add. So the RedLock solution is 100% API based. There's no software, there's no agents, there's no proxies. This is the only three pieces of information you need to provide: the account ID, the external ID, and the role ARN. This is typically a read-only access to your environment. And when I say read-only, all that means is that we are able to read the metadata about your environment. This means that we don't get access to your actual data. So for example, if you were running a Redshift database that has sensitive information, this doesn't give us access to it. This just lets us describe what's happening in your environment. And so once you would add these three pieces of information, you would click next. We have full role-based access control. So if you wanted only certain administrators to be able to see the environment, you could assign that. After that, we will then verify to make sure your settings are correct. And we will start just within an hour to start streaming that data into the environment. And so that's really all it is. Once it's set up, we'll start pulling it in. It's a very similar process for those three different environments, but you'll see that it's fairly straightforward, and you can get any number of cloud accounts onboarded very quickly. Again, there's no software or agents. So very quickly that can be set up. And then let's go through here and show you some things that are fairly interesting. So we're going to go in and we're going to immediately start to classify what's in your environment. We're going to look at the network traffic. We're going to be looking at various different things to tell you what's actually running in your public cloud environment. So let's look at here. So for example, SSH, you may ask, why do I have instances that are directly connected to the internet that are receiving SSH traffic? Maybe it's not a Bastion host, right? So let's pick on this host here. So if I click on this host, it's going to open up our Investigate tab. And this is probably where we see a lot of SOC and incident response teams spending a lot of time. This is one of the questions we get asked a lot is, hey, I see there's a command here. Is there some kind of new language or that my team would have to learn in order to take advantage of this? And the answer is no. This language that you see up here is known as our RedLock query language, or RQL. So this is standardized across all three public cloud environments. So once you have learned this very natural language type of syntax, this is the same across AWS, Azure, and Google. So you execute one command and it runs across all three public cloud environments. It makes it very easy to do incident response, research, all those types of things. And so you can see, specific for this BDF host, we've created a very immediate network mapping to give you a visualization of what's connecting to that environment. And there's a couple other things I want to point out as well. So when I click on this host, you'll notice over here on the right, we pull back all of the information about that host. Right, and what I want to point out is the alert summary. So we have integrations with various different tools. So think about something like, most people have vulnerability scanners that they've already invested in their environments, things like Qualys or Tenable. We integrate today out of the box, and we pull all of that information via API into the console so that your teams don't have to jump back and forth between tools, and also so they have the context in one screen. So for example, when you look at this here, you can see that we found some host vulnerabilities for this BDF host. And so if I click on this, it's going to go into our Resource Explorer. And here enough, you can see here's all the host vulnerabilities, when they were discovered, and it's all here right in one screen. Now, a really great piece of functionality that a lot of teams really like is the audit trail. So for every resource in your environment that we discover, we will keep an audit trail. We like to call this our cloud DVR. This lets you know everything that's happened. This, when you're doing incident response, or you want to understand what's happened for change management in your environment, we give you a single place where you can come in and to understand what changed, who did it, and it gives you full attribution. So for example, you can see here, October 10th, we discovered 3 vulnerabilities. You can see here, hey, somebody changed something. It highlights it, it does a diff, shows you what changed. And you can see when they made this change, it actually generated an alert. It probably tripped one of the policies that I'll show you in the next few minutes. And then if you were interested, we pull back the actual JSON. You can see the actual low-level syntax of what changed in that environment. So this is very nice. You do not get this out of the box from any of the cloud providers. We aggregate all this information and we pull it back really into one place where not only do we aggregate it, but we actually help you to make sense of it in context. So let me pop back over here. I want to show you a few other things in here. So you'll notice that we've identified some of the traffic coming to this host as suspicious. So you're probably thinking, okay, how do we know that traffic is suspicious? It's easy. So by default in RedLock, we embed threat intelligence information. And so we will use some known bad actors, we'll apply that to the data, and we're able to tell you that there is potentially nefarious traffic that is coming to your environment. So you can see here over on the right-hand side, we've accepted some traffic. That's not something that has not made it to the environment. It's very clear, and it becomes really easy to pull back and to get a sense of what's happening in your environment. And so you can see here, it'll tell you, where the traffic's coming from, why it was classified, when it was, and if the traffic was accepted, and then we'll map that for the period of time that, of course, that you've specified. It's all configurable. You can look at it for any period of time. You can customize it, go back as far as you have data for that asset. So it's very easy. It's very helpful in terms of when you are doing investigations into what's happening across your public cloud environments. The other thing I'll point out too is right now this is just showing north and south traffic. It's just showing what's coming from the internet into your environment. But if I double click on this, it's going to actually expand and show you all of the east-west traffic that's happening in your environment. And so this again becomes very useful for when you're doing investigations. We know that attackers, once they do compromise a host, they begin to look to see what else is in the environment. And this very easily gives you that view of in context that you don't get natively with any of the natively from any of the public cloud providers today. And so that's very, very useful. And you can continue to build this out. You can continue to double click and see where the traffic is going, what's happened, understand how things are connected in your environment. And you can see that there's also a lot of other hosts here that have vulnerabilities. And so this is it from the investigation perspective. The next thing I want to point out is just our secure tab. So this is where you define policies in RedLock. And today we ship with just over 200 policies by default. These are just ones, again, we mentioned at the very beginning that there are some policies that have come from our CSI research. And so these are the result of that CSI research that we continue to do. Now the platform is updated on just about a monthly basis. There's a new release. It is a SaaS-based platform, so there's no software that you need to manage. It is a multi-tenant SaaS application. It is SOC 2 Type 2 certified, so it's very secure. And basically we're releasing these policies on almost on a monthly basis. And of course, you can create any new policy you like as well. You can do that. You can take existing policies and extend them for your own use. So probably one, we talked a lot about S3 at the beginning and just, how this is something that's making the news. So let's look at this, right? So here's one, S3 buckets are accessible to the public. If I click on this, you'll see here's the description. You'll see that we've mapped it to a compliance standard, and then we're automatically creating for you the query to find this, right, in your environment. We've mapped it to a compliance standard. This is where it comes. We'll talk a little bit about more compliance in a minute or two. And then we'll come over and we'll click next. So this shows you what remediation will take. So not only will we discover and tell you this has happened in your environment, but you have the option to have us automatically remediate this for you. And so, for example, if you just say, hey, in your public cloud environment, you never want to have an S3 bucket that's made public to the internet, you can choose, there's certain ones that you want to exclude from that. You can use the RedLock tool to very easily make sure that you never end up in the news for having an S3 bucket. And so there's two ways you can do that. One is the auto remediation, which is once the policy is in place, if we happen to see that one of the developers or someone in your environment has made a S3 bucket public, we will automatically set it back to private and then send a notification. Or sometimes maybe you don't want fully automated, maybe you want to have a human come in and do that. You can use our one-click remediation where maybe a SOC analyst or someone comes in and they click on the button and they can auto-remediate that. So we'll actually allow, you can have either one of those two set up. So this is just giving you a high-level view there. Now the next one I'll point out is around compliance. So a lot of times what we see is that a lot of times there is some very large compliance projects that come out. So maybe you're still in the process of moving to the cloud, and let's say, for example, maybe you fall under PCI. Today in the platform, you can see here, these are the compliance standards that we support out of the box. A lot of organizations have moved toward using, for example, the Center for Internet Security's benchmarks, and you can see that we support all three of those today: AWS, GCP, and Azure. And so these compliance reports, these are not static reports. These are updated about every 15 to 30 minutes for your public cloud environments that are being monitored. And I'll show you an example. I've already downloaded one before, but this is an example of a PCI report. And you can see it's for PCI DSS 3.2. It shows when it was generated, what is the period of time that it's used for, what are the cloud accounts, and it gives you a very nice formatted picture, and it's all hyperlinked too, so you don't have to spend a lot of time. What we hear from a lot of companies that are using this is actually a big cost avoidance for them. Instead of having to go out and collect this information manually, they're able to use these reports to hand to auditors, and they're just updated, every 15 to 30 minutes. And so, for example, if I click on this link here, you can see it gives all information, what happened, what failed, but then actually how to go and to correct that specific issue. So this is very useful. It can really help jumpstart some projects that maybe are running into some walls with compliance reasons. So the next one I want to show you here is the alerts. So when you have policies in a platform, they generate alerts. And so we have integrations with many different tools. So for example, a lot of times we see customers utilize the RedLock platform really as not as their cloud SIEM, but they will begin to aggregate cloud logs, security type logging in our environment, and then they will connect it to their enterprise SIEMs. So things like Splunk, QRadar, we support all of those enterprise SIEMs out of the box today. And so you can take alerts and funnel those alerts back into your on-premise SIEM, whatever it might be. And you can see here that some of the alerts are you can automatically remediate. If I click on this will show you some of the ones that we can automatically remediate. You mentioned earlier, I showed you about how S3 buckets. Here's an example of one where they chose perhaps not to automatically remediate. They said, hey, I want to have a human come in and actually click the button. You can see here that if I would click on resolve, it would give me the option. It would say, hey, here's the command that we're going to run. If I would click execute command, then we would go and do that and then report back. So this shows you some of the alerts that have come through. And I want to show you another one here. And this is what I think is really important about the platform is, we talked about being able to detect anomalies in your environment and just how, it becomes very difficult for a human to do this. So part of the value of what RedLock adds to your environment is we have machine learning as a part of our artificial intelligence in the environment where we are going to baseline what is normal from a network perspective, what is normal from a user activity perspective, and then we bring all that back in and we will generate anomaly-based alerts. And so here's an example of where we have seen some unusual user activity. If I click on this, it's going to pull back all of those for our specific environment. And so we'll just pick on this first one here. You'll see that we do risk rank everything, A through F. In this case, this has been an F ranked resource. If I click on this, it's going to pull back some additional information. It's going to say, hey, we think you have a potential compromise of your access key. And it'll give you some of those reasons. But I can get a visual if I click on the investigate tab right here. This gives you a very easy way to understand what's happening in your environment. And specifically for this user, Tim, you'll see here we're looking at what's happening with EC2, IAM, S3, and also signing in directly to the console. In this case here, you can see that, this black circle here shows usual activities. These are the things that Tim does on a normal basis. And as you can see, as time goes on, we've started to say, hey, we think there's some suspicious activity. And you can click on these and then it will update below and it'll start to tell you, here are some of the anomalies that we potentially think. And probably more to worry about is very recently, you can see here that we can see here in this one here is that it looks like there is about 135 activities that we believe are as the result of a compromised access key. So if I click on this, it'll come up with some of those anomalies below and it will start to show you, hey, Tim is starting to do things that he has not done before in your environment. And this gives you the ability to go in and you can actually alert on these types of things. Again, you don't get this level of visibility with native cloud provider tools, and RedLock gives you the ability to do this cloud research across all of your public cloud environments, AWS, Azure, and Google, all in one console. And so that's what I wanted to show you guys in terms of the actual application. And we have a lot of really great customers. This is just a quick sample of some of the customers that have adopted RedLock today. And the thing I want to point out here is that you have cloud native customers like Workday that are born in the cloud. And then you have some other very larger, perhaps more traditional companies, right? So think about VMware. VMware is one of our largest customers. They are using RedLock to help manage both the security and as well as compliance in their public cloud environments. And so if you're interested in doing a proof of concept, POCs with RedLock are very simple, very straightforward because we are 100% API based. So it's a 4-step process. Number one is sign an NDA, right? So we have to sign that with Palo Alto Networks. This really works at the speed of your legal team, right? So get that NDA signed. That's the first step. After that's done, the second one is granting us that read-only API access. This really takes maybe 10 minutes maximum to be able to do this, and we'll get the provisioning details from that. And then after that, the third step is we will begin then over the next 2 days to start to ingest that data from your environment. It usually takes about 2 days. And then last but not least, we'll give you a customer readout. So we'll set up a workshop. We'll show you here, this is what we've learned about the environment. We'll review the findings with you with some recommendations for how to operationalize that in your environment. Answer any questions you have. That's typically about an 1.5 to 2 hour workshop. After that, we turn the environment over to you to be able to go through whatever else you need to go through for your proof of concept. Very quick, very straightforward because it's 100% API based, and we typically see some really great results and oftentimes some pretty shocking things in the public cloud environments. So at this time, Charlene, if there's any questions, I'm more than happy to try to answer those. If there's any that we don't know the answer to, we will definitely follow up with you directly. So if there's any questions, more than happy to take those at this time.
Yeah. Okay, yes, we do have some questions in, but there's still time. If you have a question for Matt, go ahead and use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can. The first one, Matt, is can you explain how the RedLock solution is deployed?
Yep, so it's a great question. Probably one of the first ones we almost always get is,
Right.
So RedLock is 100% API based, right? And the platform, there's nothing for you to actually deploy. So it's a multi-tenant SaaS application. Our RedLock application runs in the AWS cloud, and we would set you up with a new instance for your company. And then literally you would log in, you can use SSO, plug it into your SSO. If you have 2-factor authentication, that will work with RedLock. And once it's done, as I showed you in the actual demo, you just go in and you start to set up your cloud accounts. Now, if you have many cloud accounts, some organizations do, some have hundreds, some have thousands, we will script that. So we have a script that will very easily add any number of cloud accounts in a very, very short window of time.
Okay, next question. How do you get visibility into network traffic?
So that's another great question. So all of the cloud providers offer flow logs. So for example, think of in AWS, so they have their VPC flow logs, there's Azure flow logs, GCP flow logs. So specifically for Azure and for AWS, what we do is, as long as you have enabled that functionality in your environment, we will begin to pull that data in via API, and then we do all the correlation. So think about it. A lot of times for example, in AWS, when you have those flow logs, those network flow logs, they don't really give you directionality. When we pull that data into our environment, we make sense of that, we sort it, and we show you the directionality, north, south, east, west. So we do it all by API. That's how we get that visibility down to the network layer across your public cloud environments for Azure and also AWS.
Okay, great. Again, if you have a question for Matt, go ahead and use your GoToWebinar control panel and get that question in. The next question here, what compliance standards do you support? I think you may have already covered this, but just to let folks know again.
Absolutely. So I think probably the best way to do that, just so I just keep us honest, is so if you look at your screen again here, these are the standards that we support today out of the box. So HIPAA, GDPR, SOC 2, the CIS standards for all 3 cloud environments, PCI DSS, the NIST CSF. But you can also extend this, right? So maybe you have chosen to utilize, for example, any one of the CIS standards. You can then take what we have in here by default, and you can create your own custom compliance standard. I'll also note that we do continue to add new ones. I know that NIST 853 is something that is very, very near term. That's something that we're hearing from a lot of customers, especially those that are in the federal space.
Okay, all right, great. Our next question, can you detect host vulnerabilities such as Spectre and Meltdown? Good question.
That is a great question. So yes, we can. So we do see down to the host level. So there's two ways, actually three ways that we do this. First is, so example, if you're in AWS, if you are utilizing the AWS Inspector agent, we will take that data by API and we'll pull that back into the console. So I think I may have shown that earlier in the demo. We will pull all that back in. Now, if you're not using the AWS Inspector or any one of those types of agents, most organizations either have like a Qualys or a Tenable. Again, if you have either one of those vulnerability scanner tools, we will pull that in. Also things like Rapid7, we can pull that data into the environment, into RedLock, and be able to give you that context all in one console.
All right, great. We have a few questions left here, so we'll go ahead and get through those, but just a quick reminder, there is still time. If there are any more questions lingering out there, go ahead and use your GoToWebinar control panel and send it on in and we'll get to it. Next question then, so can you detect host compromises?
We can, right? So some of the, again, this is somewhat similar. So we're able to detect host compromises because we're able to see down to that host with those vulnerability scanners. Also, because we're able to pull back the network traffic, as long as that network traffic is leaving that host and it's hitting the network, we're able to see that at the host level because we're, again, the vulnerability scanners, we can say if there's a vulnerability on the host, but we can detect it down to the host level again, because most likely if you've had a host that's been compromised, that traffic is going to then leave that host because otherwise, why would they attack your host, right? So we'll be able to see that because of the data down to the network layer that we have in the RedLock platform.
Okay. All right, great. Looks like our last question here, unless we get any more in the next minute or two. What integrations do you support?
So today there's quite a few that we support out of the box. I mentioned already Qualys, Tenable, but also in terms of enterprise SIMs. So we support Splunk and QRadar natively. And those are the ones that we support natively, but because we're an API-based platform, it's very straightforward for us to be able to integrate with other things. So for example, it's not very easy to do email-based alerts. We have integrations out of the box with things like Slack and Jira. The Jira integration is one that we have, it's become very popular. So if you are an environment that is very DevOps friendly, most development organizations already are using Jira. And so what you can actually do is you can create a complete closed loop cycle. So if there's an alert that's generated in RedLock, there's a policy that's been violated, you can very easily log a bug over in Jira and have your developers address it directly. And we'll pull that back. This isn't just dumping data into Jira. We actually pull back your specific custom Jira templates that your developers have created, and we will populate that with all the necessary information so that they can fix it as they would fix any regular bug in an environment.
All right, great. Well, as I said earlier, that was the last question, but there is still time. If you have any last minute questions for Matt, go ahead and submit it. While we're waiting to see if any more come in, I do want to remind the audience that today's event is being recorded. So if you missed any or all of the event, or if you just want to listen to it again, just know that you'll be receiving a link after the event. In fact, everybody who registered will receive a link to the event in an email. That should be coming very shortly after the end of this webinar. So the webinar is also going to be living on the Security Boulevard website. So if for some reason you don't get the email or you lose the email, you can always just go to the Security Boulevard website, click on the webinar section and on demand section, and it should be there waiting for you. And then while you're there, you can also check out any other of our many webinars that we have, both upcoming and on demand. Hopefully there'll be one or two that pique your interest. And it looks like we have received no more questions. So Matt Chiotti, thank you so much for giving such a great presentation. Super, super important information. So thanks again, I appreciate it.
Thanks, Charlene.
Also want to thank the audience for joining me today. Thanks for your attention and thanks for your questions. Certainly lots of really good ones there. So again, I just want to say thank you. And this is Charlene O'Hanlon giving you 5 minutes back in your day. Have a great day, everybody.